Hello everyone, Siddharth this side, and in this video we will be solving another question from the list that I have shared with you. And the question is sum of square numbers. So this is has 633 on lead code. So let's read out the question first. So we have given a non-negative integer named as c, and we have to check whether there exist two integers whose sum whose square sum is equals to the value of c. So let's see how we can approach this question. So let's take the first example, which is 5. So c is equals to 5. Now we have to find two number a and b such that the square of these two numbers and their sum should be equals to 5. So we can take this as 2 square plus 1 square. This is equals to 5. Now how we can approach this question? So again we are solving this question in the pattern series. So obviously we will be using two pointers because currently we are on two pointers approach. So now I would say that you can pause and think for a moment how we can solve this question using two pointer. So let's move on. So what we can do, first let me tell you something. So a square plus b square is equals to c. Now what we can do, we have to find the maximum value that a can take so that we can limit our end pointer, because start will start from 0 and end we have to limit this because we can limit that. That's why we are limiting it, so that we can reduce the time complexity. You will soon understand. So suppose there is no b here, there is only a. So a square is equals to c. So the maximum value that a can take without even adding single thing into a to become equals to c, that will be root of c. uh, yeah, that will be root of c. So the maximum value that individual element can take, it should be equals to the root of that. So we can use this concept to limit our end counter, that the maximum value that the end pointer will take is the root of the value. So now let's code this out. So this is the only approach that we have to use in this question. And to some question I have already solved in this playlist. You can go and check that out. And then you can get the approach how we will be solving it using two pointers start and end. And this is very easy question. If you don't even like see that video, you can easily understand from here also. So let's move on. So first we have to make start pointer, and it will be equals to 0, and end will equals to the root value of c. So how we can do that? We can use the math function sqrt, and we will be passing c to it. So the maximum value that end pointer can take is the square root of c. Now what we have to do, we have to apply the same approach, the two sum question approach, which is while start is less than or equals to end. In that case what we have to do, we have to first calculate the sum of the sum of the numbers, which is start and end, and then we have to square those and add that. So for that, let's make a variable sum, and then we can use long here because the value of sum can exceed. So long sum is equals to, now we have to square start and end. So for that we can convert this as well into long. Okay, now we have to do start into start multiply with start. Okay, and we have to add this with end into end. Now after doing this we have to check simply we just have to check if this sum is equals to, if this sum is equals to the value of c, then we just have to return true. That's what we have to do in this problem. And otherwise, if the sum if the sum is less than if the sum is less than c, then we have to increase the sum. For that we have to move to the right side. So we can do start plus plus, and otherwise we have to decrement the end counter. So for that we can use end minus minus. And after doing this, if we will not able to return true from this loop, then in the end we just have to return false, because there is no such uh, duplets present from the start to the end of this number whose square sum is equals to the value of c. Okay, now let's try to run this question. So okay, so there is some issue. So we have to convert this because this will be double value. Now we can run this question. Okay, now let's try to submit this as well. So we have successfully solved this question. See you in the next video where we will be solving the next question from the series. Bye.